So after knowing the first very basic concept, now let us deal with one more example. And I suggest that after looking this example on the board, kindly pause the video and try to solve this example on your own. Fine. So we will understand how much we have understood about this topic and concept. So let's start with this new concept in KCL. We have such network, which is a very good network. Yes, this is where we have a resistor. 10 ohms, 10 ohms, this is 2 ampere. We have plus minus 3 volts and this is 5 ohms. Volts and 4 ohms. We are interested to calculate node voltages V1 and V2. This is the datum node or grounded node. So I request all of you to just go through this example by pausing this video, and we people will start with the solution. See, what happens is let's understand what usually a student is doing into this kind of example. What they'll do, they'll apply a basic fundamental thing that we are having current coming, and current is coming. So the addition of all three current is equal to 0, right? Okay. So I'll say that I1, say this is I1, this is I2, this is I3. So I1 plus I2 plus I3, that is equal to 0. Fine. And here also we can make another equation. So let's say that equation is like this. We'll do it with blue. So we are having this I1, this is I2, and this is I3. Again, you can take any direction you wish. Fine. Okay. So let's write down what does it signify. So 2 ampere current is coming over here. This resistor is connected in series with this 2 ampere current source. So this becomes abundant branch. Fine. So we will short circuit the resistor or we will neglect the resistor. So that is the very first thing that we will do. Fine. So it's gone. So here I can say that I1 is 2 amperes plus I2 is flowing like this, 0 minus V1 upon 10. 0 minus V1 upon 10 plus I3, this current. How to write it? V2 minus V1 upon 3. Students generally what they do, it's V2 minus V1 upon 3 is equal to 0. Now V2 volt, V1 volt, 3 volt, volt upon volt cancel. This becomes a constant term, whereas it has to be current, ampere, voltage upon resistor, ampere itself. So this is not correct. So generally people are making this mistake. Do you understand? Do you understand this? What kind of mistakes people are making? So why? How this example is different? Fine. So let's say in KVL, in mesh analysis, we people have understood one thing, that if in between two loops we have a current source, then that entire thing becomes a super mesh, right? Similarly, if in between two nodes we have a voltage source, that becomes super node. Do you understand? Fine. So if it is a super node, you cannot solve it conventionally. So what to do for the solving this kind of examples? So this is the portion that we consider as a super node. Fine. So I'll redraw the entire network. Let's see. This is 2 ampere. Fine. Resistor is short circuited. This is 10 ohms. This is 3 volts. This is 5 ohms. This is 4 ohm. 10 volts. Okay. Now, if in between any two nodes if we have a voltage source, if in between any two nodes we have a voltage source, that is considered as super node. That portion, that part of the network is considered as super node. And what will we do? So first thing we will remember that we will consider one current, into it which is flowing in specific direction, and we will not change that current direction. Fine? We will consider the current in that particular branch is flowing in this direction only. Is it clear? Fine. Generally, if this is positive, negative, we can take current this way. Fine. But it's okay. We are assuming the current, right? So we can say that the current is like this, say, and this current is I, and I am not going to touch this I. Clear? Fine. So now what you were saying will come into picture, that it will never be like this, that all currents are coming inside the node over here. One current is going, one current is leaving. Is it clear? So now let's say how things are working. I take rest of the currents. I1, I take this as I2. So two currents are coming inside, one current is going out. Okay? And here what will happen? Okay, fine. We have to consider one node as well. So this is one node V1, another node V2. Is it clear? Fine. Now let's say here we consider one current is coming, this second current is also coming, I1, I2. This becomes, say, I3, and two currents are coming in. Say fourth current is going like this, I4. Is it clear? So I can make two KCL equations over here. I can make two KCL equations, one from this node, one from this node. So let's write down the KCL equations. First equation, at V1. Fine, I'll say that I1 plus I2 is equal to I. We won't touch this I. Let's keep it blue. We won't touch this I. Clear? Fine. No touching. Only seeing. Okay. Now let's say I1. I1 is what? It's 2 amperes. It's 2 amperes. Plus, what is I2? 0 minus V1 upon 10. 0 minus V1 upon 10. And that is equal to I. I've got my first current. I've got my first equation. Fine. Okay. Now, let's solve it a bit. I guess it would be preferred. It's 2 plus, sorry, this is minus. So it's 2 minus 0.1 V1 is equal to I. So this is my first equation. Clear? Fine. Second equation, let's make at V2. At V2, we will write down. See, I is coming, I3 is coming, and I4 is going this way. So I can say that I plus here, I plus I3 is equal to I4. Fine, where are you? Come here only. Fine, don't go anywhere else. Gadbad nahi banta beta. So we have I coming, I को touch नहीं करने का, let's say it's I. Fine, plus I3 is coming, it is equal to I4. But I will always keep I different only. So we have, say, I that is equal to, यहाँ पे भी I will be differently writing this I. So I is equal to, what will we have? It's I4 minus I3. So it's equal to, I4 is what? This current, V2 minus 0 upon 5. So it is V2 minus 0 upon 5. Minus, what is I3? Here I have 10 volts. 10 minus V2 upon 4. Is it clear? 10 minus V2 upon 4. So this is what is my I3. So again I have got I, which is equal to I, which is equal to 1 upon 5 is 0.2 V2 minus 10 by 4 is 2.5 minus plus 1 by 4 is 0.25 into V2. Is it clear? Fine. So I have got another equation. You know, this equation is having two unknowns. This equation is also having two unknowns. So I have two equations with three unknowns. We cannot solve it. Is it clear? Fine. What will I do? I'll compare these two equations. This is I. So I'll write down, I'll simplify it, 0.2 plus 0.25. So that's 0.45 V2 minus 2.5, which is nothing but my I. So I've got another equation of I. Is it clear? Fine. This is also I and this is also I. So we can compare and get one equation. Fine. So I'll say that from equation number 1 and equation number 2. So I'll say that from 1 and 2 we can say, from 1 and 2 we can say 2 minus 0.1 V1 is equal to 0.45 V2 minus 2.5. So I'll adjust these things and I'll be having I'll take this over here, so it's 0.1 V1, it will become positive. This is already there, plus 0.45 V2, fine, and I am taking it over here, but I am writing it that side, so I can say that this 2 plus 2, that is 4.5. See, if you are getting confused with this particular step, you can pause the video, you can see how I have taken this term over there, which will become positive, 0.45 plus 0.1 V1, that I have written over here, and this time I will take it over here. 2 was already there and I have added 2.5 into it, so I have got 4.5. Is it clear? Fine. Okay. So again I have got one equation, but I have still two unknowns into it. So we can say that see, one equation and two unknowns, we can never get the answer. Fine. So it is compulsory for me to get another equation as well. Is it clear? Any doubt on this? Fine. So how will we get that equation? So now this entire portion will play a very big role. Fine. This super node portion will play a very big role. So we'll take only this part. Let's say I have plus B1 here. Okay. Fine. I have I'm so sorry, I have 3 volt plus minus 3 volt over here. Fine. And I have V2 over here. Fine. Okay. Which is plus V2 only. Now I will apply KVL into this. Sir, how can we apply KVL in a rhyme? I have told you, the moment I have started this chapter or topic, I have told you that when we have something like this, it is basically a network. It is a network like this. I can say it is. Right? This is a network having such voltage sources. Now we can apply KVL. So let's say with respect to ground, this is V1. So this is plus V1. Is it clear? This is V2. So with respect to ground, this node is V2. Now, beta, we will apply KVL, right? So we will apply KVL over here like this. Irrespective of the direction of the current, we will apply KVL. Okay? So let's apply KVL. V1 का rise plus minus 3 का fall minus V2 plus minus it's a fall. पता चला? Is it clear? So I have got that is equal to 0. We have applied a KVL. I have got equation. V1 minus V2 is equal to 3. Is it clear? So I have got two equations, two unknowns. Again I can solve. Is it clear? Any doubt on this? Any doubt on this? So let's say I'll write down. This is V1 minus V2 is equal to 0. I'm sorry, it is equal to 3. Fine. So I'll multiply this entire equation with 0.1. So multiply it with 0.1 minus 0.1 actually. So let's say what will I have? I just solve it. Actually you can do this on your own. Whatever technique you know, you can do this. 0.1 because I'm writing the first equation plus 0.45 V2 is equal to 4.5. My second equation will become minus 0.1 V1 minus 0.1 V1, then minus plus 0.1 V2. I have written 0.10 just to add these things well, and it is equal to minus 0.1 into 3, that is minus 0.3. So I have got, this is cancelled out and we'll be having 0.55 V2 which is equal to 4.2. Is it clear? Fine. Yes, please calculate. So V2 is equal to 4.2 divided by 0.55, which comes out to be
7.636.
So V2 is equal to 7.636 volts. Fine. And I'll put this value in any one of the equations. I'll put it over here. V2 is equal to 7.636. Put it. So 7.636 plus 3 is 10.636. So V1 which is equal to 10.636 volts. Fine. So we got both the voltages. Is it clear? Any doubt on this? It's a very, see, generally people are making very common mistake over here, which is like this. So don't do this. See how to identify given example is of super node. We will understand it this way. If in between any two nodes we have a voltage source, that example is considered as a super node. Clear? Fine. What to do? So we will consider a current into that particular branch that we won't touch. Is it clear? Is it clear? Then what will we do? We will make two nodal equations. We will make two nodal equations over there. दो nodal equations बनाए. Then what will we do? We'll be comparing those two equations and get one equation with two unknowns that we cannot solve. We will be having one equation with two unknowns by using first node and second node. Fine? Okay? After doing this, what we have done? We have taken up the entire portion of super node. वहाँ पे what we have done? We have taken V1 and V2. We have found the relationship in between node voltages in given voltage source. We have calculated a relationship in between node voltages with given voltage source. Is it clear? Is it clear? Bagasa boy? Is it clear? Fine. So I hope the entire concept is clear to all of you. Pata chala? Fine? Right.